In this video, I'd like to teach you how to name and write covalent compounds. Covalent compounds, also referred to as molecular compounds, are composed of two or more nonmetals, and these share electrons. Now, I'd like to say you're going to fully appreciate the mechanism behind this once we get to our bonding unit. But for now, I want you to hopefully make a distinction between what I'm saying here and the previous 3 videos in this unit. In the previous 3 videos, we were discussing ionic compounds. In this video, we're looking at covalent compounds. For example, water and carbon dioxide. And there's a huge difference between the structure and the bonding of these compounds. So in the previous 3 videos, we looked at ionic compounds, and I want you to write this down. Ionic compounds donate and accept electrons to assume a positive or negative charge. And I've verbally mentioned that in Nomenclature 1, 2, and 3, but it is absolutely imperative you understand that to make a distinction between ionic compounds and this video where you're going to be naming covalent compounds. So what do we know? Well, we know that metals give away electrons to become positively charged. We know nonmetals will accept electrons to become negatively charged. And we know that based on Coulombic attractions, these positives are attracted to the negatives, so in ionic bonding, they come together. In this video, I'm going to teach you how to name covalent compounds which share, to some extent, electrons. So, if we look at the periodic table, you will notice that these species are to the right of the stairs. Okay? So that's a big deal. So we're not looking at any of the elements that you colored in blue in Nomenclature 1 and 2. Those are metals. We're looking only at our nonmetals to the right of the stairs. You're going to be using Greek prefixes when naming covalent compounds. Pause the video and write down the Greek prefixes for the numbers 1 through 10 at this time. All right, so let's look at adding these prefixes to both elements in order to name these covalent compounds. Of course, as you will see in almost every video I make, there are some exceptions. In this case here, minor exceptions avoid double vowels when using the prefixes. For example, here where you have hepta and oxide, you have a double vowel, and that is referred to as heptoxide, where the A in hepta is omitted. Now, it's not very important to me, but I want to make you aware that there are these exceptions. We're going to get right into practice problems in this video. So here we have a compound. Did you look at the periodic table? Oh, they're both to the right. Well, that means it's covalent. That means they're sharing electrons. And that means we're using Greek prefixes to name it. How many phosphorus are there? 2. How many oxygen are there? 2. 5. So for 2, we use the prefix di. For 5, we use the prefix penta. So this is diphosphorus pentoxide. Now notice the A in penta has been omitted to avoid this double vowel. Diphosphorus pentoxide. How about this one? And feel free to pause the video and do these on your own. They're relatively simple. So we have 4 nitrogen, and we have 10 oxygen in this covalent compound. Well, the prefix for 4 is tetra, and the prefix for 10 is deca, so this is tetranitrogen decoxide. Again, we've omitted the A to avoid the double vowel. Let's look at this. I put this one in on purpose here because many students will immediately say, oh, that's sulfite. That's a polyatomic ion, sulfite. No, this is not sulfite. This is sulfite. And sulfite has a -2 charge. This is something called sulfur trioxide. Sulfur trioxide. And oftentimes the mono for the first species is omitted. So you may say this is monosulfur trioxide. It's referred to as sulfur trioxide. So think of like carbon dioxide. We don't say monocarbon dioxide. We say carbon dioxide. All right. Again, not very critical points here to make, but I'm still going to mention them so you have a full understanding. Here's what I'm going to ask you in class when naming covalent compounds. Did you look at the periodic table? Yes. Why do I ask that first question? To avoid careless mistakes that often occur in this first unit. If you look at the periodic table, a lot of times you will avoid those careless mistakes. Are both species to the right? In this case, yes, they are. Then here's what you're doing. You are simply naming covalent compounds using Greek prefixes. Let's get some practice writing the formula. So pause the video and try to write the formula for this compound. We have dinitrogen, which means there are 2 atoms of nitrogen, tetroxide, which means there are 4 atoms of the oxygen. And so this is the correct formula for dinitrogen tetroxide. In this video, we've continued to look at our Georgia Standards of Excellence, except now you are able to name covalent compounds, which leaves us with Nomenclature 5, where we're naming acids. And I'll see you guys in class.